Okay, welcome. This is one of the saddest moments in any online conference that I've ever hosted. This is the beginning of the last talk. We've had such a wonderful time so far today, and I know that Tim's going to bring it home and close us out real fun. I told you at the beginning I'm known for butchering names, and I've known Tim forever, and so I was actually going to introduce him as Tom Lytle, but I'm not going to do that. Please do me a favor. Welcome my good friend, Mr. Tim Lytle, as he talks to us about HTTP patterns, PSR 7 and 15 by example. Tim, you with us?
I am, yep.
Okay. It's all up to you now.
All righty. Well, once upon a time, I think Programmable Web listed me as Tom Lytle, so you would not be the first. But so I ended the conference, so I guess we'll start with some live code, right? Hopefully not everybody's too tired. I know it's after lunch for a lot of you, but we're going to take a look at some code examples, and hopefully I'll keep it exciting enough to keep you awake as we end this conference. I asked a poll question: who's used PSR 15, and who's used PSR 7 in the past? And I think what I heard was the results are about 50-50. So we're going to look at those by example. And even if you have used them, because the truth is probably most people who are PHP developers have consumed them in one way or the other, even if they haven't done too much with them. If you've used a popular HTTP client, you've probably been using PSR 7 in the request and response if you don't, even if you don't realize that. If you have been using something like a micro framework, a lot of micro frameworks use PSR 15 as well as PSR 7 for their requests and how they operate and their leverage of middleware. So we're going to take a look at those, kind of dig under the hood a little bit, and see what you can do with them today in this no slides, just code talk. So let's start with well, really, actually, once upon a time, it was difficult to make a HTTP request in PHP. You had a couple different ways, but there weren't established libraries. Then came around libraries like Guzzle, which made it a lot easier, and then came around the PSRs to help create some interfaces around this. So if we're using different libraries, we can pass requests and responses, and if they conform to the interface of PSR 7, we can give another package, say our HTTP request, and let it do something. And there's that compatibility. If we're all using PSR 7 to represent our requests and responses, we can use other code to standardize that and make it easy to use other libraries with the code that we're writing, and then also make our code portable. So if we switch a library, not much of our code has to change. So let's take a look at this. First of all, PSR 7 is the request and the response PSR. So it creates interfaces to represent HTTP requests and HTTP responses, which as PHP developers, we know that is most of what we do, right? We're handling web requests. Let's take a look at some code here. You can see I have a request, and I'm using this, well, it used to be Zen, now it's Laminos, their Dactros library, and they have a nice method that lets me create a request from globals. So that's going to use things like our superglobal post, our Git, the server superglobal, and it is going to create something that represents an HTTP request. And then we can do a couple things with it. We can see, I can get the URI, and that's going to be an object. It's not going to be a string, but I can get the URI, which then I can say, hey, give me the path for that. And I don't know if I'm the only one here that's had this struggle before, but before these well-defined request objects, trying to remember which variable in the superglobal array I wanted to get the actual path. I always struggle with that. I'd always have to look it up in the manual, and I always have to dump some variables to make sure I got the right name. We can see it's easy to get a header, so we don't have to use the PHP built-in header function to get a header. I can just ask the request, hey, give me the line for content type. I can get my query params as an array. I can get my Parse Body if I've sent something that was parsable, and I could just get the entire contents of the body. So this is what the request object gives us, this shape that we can use to inspect the inbound request. So if now this, I'm using PHP Storm here. If you don't know this, here may be an interesting tip. PHP Storm has a built-in HTTP client, and you can just basically structure the HTTP request. Here we're saying I want to make a post to basically my index.php, right? And I'm going to set the content type as application form URL encoded, and here's my form URL encoded data. And if I hit run, PHP Storm will just run that against localhost, and we'll see. Here's the output of my application. Remember, I was outputting the path, I was outputting the header, I was outputting an array of my get vars, and I was outputting an array of my parsed body, and then also I output the body itself. So we can let's go back and let's talk a little bit then about what the immutability of this request gives us. So PSR requests and responses are always immutable, meaning you can't change them once they're created. So we've created this request from globals, and it doesn't matter. I don't know if anybody's been in a code base that does fun stuff like this, but just somewhere in the code somebody says, you know what, it would be easy for me just to change the value of the super global, because that would make it easier for my code to work. And so we just go in and we change it. So that's, I mean, I've dealt with code that does this. It's not always fun if you're trying to and are expecting these things not to change from the request. So we've got a little bit of this code right here. I'm going to change the post. I'm going to change the get var, and then I'm going to go back and let's take a look at running this again, and we'll see that it doesn't matter that I changed them. They're the same, because you can't change the request after it's been created. It is immutable. So it doesn't matter if someone comes along and starts changing our super globals. It's not going to change. Oops, copy paste the wrong thing. It's not going to change the values in our request. What's also nice is that request, there's no way, the request gives us no way to change its internal data either, which is very useful if I'm going to take this request and I'm going to pass it off to something else. Say I have another utility class, or I have another library that is going to do something based on the request from the user. My code can pass the request to that library, and I don't, from a testing standpoint, I don't have to come back and test, well, did the other library change my request? Did it modify a value? I don't have to test it because I know it can't modify it. My request is immutable. Once that request object is created, there is no way to change the internal data inside of it, with the exception of the content, because that is a stream, right? It's a file stream, basically PHP's input stream. So that could be changed. That is the only aspect of the request that could possibly be modified. And speaking of streams, let's take a look at what we can do with that body. So here we have, we're going to grab a stream and a request. We can get the body, we can detach it, and then we can append. Now we're going to make our code super secure. We are going to encode everything. So we're going to append the rot13 filter. And if you don't know what the rot13 filter is, it just rotates the letters in the alphabet 13 characters. And then we're going to just do a stream get contents of the stream. We're going to detach the stream from the request, and we're just going to echo it out manually. So let's take a look at what that looks like. If we come back here, here's our secret data, and we are going to encode this using our nifty code, and we'll see, yep, it indeed was encoded. So we can play with the stream just like any other file stream, easily get it from the request. Now, what if, though, we do need to change something about the request? Because here what we'll do is we'll dump the parsed body of the request, and I'm going to send it some JSON. And this isn't a knock on the Laminos library, but the Laminos library by default does not parse JSON. It only parses form URL encoded. So here I said, hey, give me my data, and it gave me nothing because it didn't parse it. Well, what if I wanted to fix that? How would again, I can't modify the request. So how would I get that parse body in there? Well, here, first of all, this is real simple. This is not necessarily code you should use in production, but it's a real simple check to say, hey, if I looked at the header and the content type has JSON in it, right? And PHP Storm was helpful there and just gave me a lot of information. If it has JSON in it, then we're going to JSON decode the contents. And we're going to JSON decode it as an array, and we are going to set that as the parse body of the request. But it's not really the request, it's a request that I get back from the request. So the PSR defines all these with methods with parse body. We can do with query param. We can do with a lot of things, with header. And it allows us to evolve the request, but I'm not changing this instance of it. I will get back a new instance of it. So yet again, in my code, if I give someone else the request, I never have to worry, has it been changed? They may have evolved it and created their own request. They may even return back to me if I'm expecting them to return back a request to me. They may return back something that has changed, but they haven't changed the one that I hold, the one that I got. I know that will never change. So now we just create this new JSON request from our request. We only replace or modify the parsed body, and then so now we can come back and we'll var dump our original parse body, which again, immutable, shouldn't change, and we'll var dump our JSON request body, which now, because of the code that we introduced here, should have the data that we expect. So let's take a look at that. We'll run it, and as expected, we see we get an empty array when we look at our original immutable request, and then the one that we created, which is also immutable, we will get the data that we expect. So that's how we can modify requests. Again, it's not really modifying them, it's creating a new request from a request. That's how we evolve those things. Here's something that's a pattern that might be a little bit more familiar, right? So here we're going to get the URI from the request. We're going to explode it on a slash. Then we're going to look and say, hey, do we have the first part? And again, this is part 1 because I'm already in PSR 17 as a directory. So my 0 part is going to be my root directory. Say, is there a part 1? If there is, let's call that the controller. And is there a part 2? Is there a second segment after that, after another slash? Well, let's call that the action. And then let's create a new request. If we found a controller, let's create a new request, and we're going to add an attribute to it. So with attribute is a really powerful and potentially, I don't know how overlooked it is, I feel like it gets overlooked, way to add additional data to the request that's not, say, in the context of just the request. It's not the URI, it's not the header, it's not anything like that. It's just data that you're adding to the request for use in your application. So here we say we're going to create an attribute of controller, and we're going to assign it to this new request. Oh, we found an action? Well, we're then going to create a new request, and it's going to have another attribute called action. And since I keep calling with attribute, I am building it up. It's going to have all the attributes from the past, and now it's going to add a new attribute to it. So if we go back to our example and we run this code right here, which as you can see we're hitting PSR 7/user/index, and we dump the attributes of a request, well, now we have a controller of user and an action of string. So we've been able to kind of decorate our request with information that is useful for something else, potentially, another part of our application. Finally, let's talk about what we can do with responses. So here's a response. And we can create a new response object, and just like we can modify or evolve or change a request with these by creating new instances of it, we do the same thing with the response. So I've got a blank response which has whatever the default values are, and then which is going to vary from library to library, right? And then I say, hey, I want a response with status of 201. I want a with added header of special header. So I create a special header and I add a special value to it. And I'm going to echo out the body. I'm gonna basically take the input body and I'm going to set it as the body. That same stream is my response. So what do I do with this response now that I have it? Well, I have to somehow send it back to the browser. And for that, different libraries will have different utilities to do it. For the Laminas library, it has an emitter, and you basically just give it the response and say, hey, please emit this. And what's it going to do? Well, it's going to look over, it's going to probably grab all the headers, it's going to look at the headers, it's going to say, hey, this is how PHP sends a header, and it's going to use the method that's needed to send a header. Then it's going to look at the body, it's going to say, oh, let's get the body, maybe we're going to stream the body, maybe we're going to get it as a string and then echo it out. Under the hood, I'm not quite sure what the emitter does exactly. I know it tries to do it as efficiently as possible to get the response back down to the browser. So we have a response, we have the emitter, we just say, hey emitter, emit this response. And let's take a look at this in action. We'll come back here and we'll grab our secret data, right? And we'll just run that, and we'll see, now what do I get? Well, I get an output of my secret data, because that's what I input. If I change secret data to something else, and then I ran that, we'll see, oh, secret data again. So we can just grab the same thing that we were given, and we can give it back. But because it's just a stream, let's do something nifty with it, right? We can detach the stream from the original response, or from the response, because it's, it is the response, which is the same, we got it from the request, so it's essentially the same thing as the request. We can detach that, we can append our ROT13 filter again, right? And then we'll create another copy of the response, right, with a different body. This is our new stream. This is the stream that we created using, after we had detached it, right? And now we'll emit that response, and now we have a nifty way to encode all of our data, and it's super secure, because whatever I send it, it will output the shifted characters. So that's the request and response PSRs. We'll build on those as we take a look at PSR 15, but I know they're relaying what questions they can, so if you have any questions, and I should have said that, if you have questions, put them in the comments during the talk. I'd love to answer them. If they can get them to me on Slack, I'm trying to keep an eye on Slack at the same time. So if you have any questions about PSR 7, feel free to add them, and I'll try to catch up as we get those questions coming in. Let's take a look at PSR 15. PSR 15, PSR 7 introduced the request, response, stream, URI interfaces, a bunch of interfaces. PSR 15 introduced two interfaces, a middleware interface and a handler interface. So let's take a look at those interfaces first. Here's the request handler interface, and it's really, really simple. It says we have one method called handle. You give me a server request, and I should have mentioned this when we were talking about PSR 7. PSR 7 has requests and responses, and it has server requests, which have a little bit more information than a normal request because it has some of the context of a PHP inbound request. So the PSR 15, the request handler, takes a server request interface, and it expects a response interface back. So this is essentially what every most PHP applications do. You get an inbound request, you expect a response back. So the PSR itself is relatively simple and straightforward in what it does. Let's take a look at a very simplistic handler. Here's our not found handler, which implements our request handler interface, right? We get a request, we ignore it because we don't really care, and we will just return a new text response. Now, text response is just it's an object that Laminas gives us that sets up the content type of the response, so the responding or the browser knows how to display everything. And we're going to say it's a new text response that says not found and has a status of 404. So that's a really simple handler, right? Get a request in, say, hey, I didn't find what you were looking for. Let's take a look at a bit more complex handler, and if you start seeing this, you're like, this doesn't make any sense. Why is he doing all this in one class? We'll get there. We'll get to why, and how we shouldn't and what we can do better. We construct it with a base path just so we understand where we should be, what our URLs should start with, and then our handle method says, well, get the path, check to see if the path begins with my base path. If not, throw a runtime exception. I'm not supposed to be doing this, right? If we pass that check, take the base path off of the path that I've been given, and then strip out all of the characters. And then look and say, hey, if after we've done all that, we start with traffic, well, we're going to return the output of this method. Or if after all that, we start with weather, we're going to return this other output. Or if we've gotten this far and neither one of those requests, neither one of those conditionals was matched, we're going to create a new not found handler, have it handle the request, and we know what that's going to return. That's going to return a not found response, right? Let's briefly take a look at handle traffic. Handle traffic. This is an API that will give us traffic and weather essentially. Handle traffic just basically says, is it bad or good? Is the two choices? Randomly pick one and then output some JSON data. Again, JSON response is just a subtype of a normal HTTP response or response interface that has it preset to encode whatever array you give it as JSON. So we're saying here's the status. And then we give a little icon and some friendly, the traffic status is bad. So we give a key, we give a human-friendly version, and an icon. Handle weather, very similar. We have some options. We pick one of those options randomly, and again, we output the same structure, status, friendly, and icon. So we have a nifty little weather and traffic API, and we can wire this up. Let's take a look at index.php. We can wire this up right here. We'll ignore the rest of this code. We'll just look at this. We create a new handler, we create a new emitter, and then we tell the emitter to emit the output of our handler when we create a server request factory from global. So let's take a look at how this works. If we go over and make this request, well, first let's just do this. Let's make a request to nothing, right? We have no matching URL, so we get a not found, as expected. If we ask it for weather, we see the weather or the traffic is good, and we keep in, the traffic is bad, and we can randomly go back and forth them however many times we request it. We can do the same thing with weather. Okay, the weather is sunny, cloudy, rainy, sunny, rainy. Okay, so we got random weather as well. So that works just fine. But the problem is, I'm doing a whole lot of stuff in this handler. Oh, I see a question. We will get to that at the end as to what you should take into account when you're selecting a PSR 7 library. We've got, and we'll actually kind of touch of it. Hopefully you have time on what you can do to make it even better for you. So I'm doing a whole lot of stuff in this handler. We look at it, we're like, wait, you're doing routing, and there's this code down here where we're handling two different things. Wouldn't it be better if we could just split all this apart? And it's like, of course it would be better if we could split all this apart. Let's take a look at middleware and the middleware interface for PSR 15. The middleware interface is similar to the handler, just a slight bit different. Now we have a process where we are given a server request interface. Ooh, that's the same, right? We expect a response interface in return. That's the same. But here's the new introduction. A middleware expects also to be given another handler. So I act kind of like a handler in that I have a request and you expect me to give you a response back, but I also get another handler. So let's see what this allows us to do. We'll take a look at a route middleware. Now this is going to look a lot like some of the code in our traffic and weather handler. We get a base path, an array of paths, so we'll set those when we construct it. And then when we process this, we take a look, just like before, we take a look at our path and say, okay, give me the path. So I have the path, and then we check to see, did I start with what I was configured as my base path? And if not, I don't throw an exception. No, I just say, oh, this must not be something I can do anything with. Let me let the other handler handle this. Whatever handler you gave me, I'll just pass the request on to them and return their response because I know they'll have a response. If that's not true, if I did match the base path, then do some operations on the path, extract the base, take the base path off of it, trim it so we have no slashes, and then explode it on slash. And then here, this is a little complex, and I probably shouldn't have added it, but I did. We look to see if we actually were given, if paths is not empty. So if we were given a set of acceptable paths, we check to make sure that this path is in that acceptable paths. And if not, do we throw an exception? No. We just return the next handler. If, though, we either don't have any list of acceptable paths, or if it did match it, we look at it and we say, okay, we're going to modify or evolve this request. We're going to add the attribute of route to it. And that's going to be the first segment I matched. So whatever came after the slash of my base path, I'm going to set it to be the route attribute. And then I'm going to look and say, hey, when we exploded it on slashes, did we have another segment? If so, I'm going to add that as the ID to the request. And you see, we're not really adding it; we're getting a new request, right? Because right here we traded our request for now a routed request, and then here we just replaced routed with a new routed request, right? And if I was able to do that, then what am I going to do? I'm going to still call the handler I was given, whatever handler was passed to me. I'm just going to give it the routed request instead of the original request, like I would if it was something I couldn't handle. So now we're able to pass a request through this middleware and expect that we will extract the route details from the path. Now let's look at another middleware that might be able to use this. Here's a middleware that's constructed with an array of handlers. And its process, well, what does it do? It looks at the request it's given and says, do I have a route attribute? And if I don't have a route attribute, or if I do have a route attribute and it doesn't match the array key of one of my handlers that I've been given, or if I have been given a handler, but for some reason that's not of the instance request handler, then what am I going to do? Throw an exception? No, I'm just going to let the next handler handle it. But if for some reason I do have a handler that matches the key, that whose array key matches the route that I found in this request, then instead of passing it on to the next request handler, I'm going to handle it myself using the handler I was constructed with. So now if we create a couple handlers and we say, hey, for the route weather, use this handler, for the route traffic, use that handler, and somehow that route gets populated in the request, I will route that request to that handler. So let's take a look at those handlers really quick. We have our traffic handler. Well, this is really simple. This is really testable, right? Now I can just say, oh, do I randomly give back the right JSON status? I sure do. I can test this so easily. And our weather is also pretty easily testable. And the truth is, our two middleware are really testable. One of them, we just say, if given a path with the right structure, it populates the request that it passes on to the next handler with the expected route and ID. And then my routing middleware is really easy to test because it says if it found a route and it has a handler whose key matches that route, pass it to that. If not, pass it to the next one. So the tests that I can write for this code are amazingly straightforward and really easy to do. So here's our weather handler, same thing. It's basically just extracted from that part of our original code. And this, again, really easy to test, really easy to change. So let's wire them all together. Well, before we do that, we actually need to have something that calls and sets up and executes and kind of passes the right data to each one of these middleware. So for that, we have a stack handler. Now, stack handler isn't middleware. It's a request handler interface. So this is something we could just give a request to and expect to get a response back from. We construct it with a request handler that we call the fallback. In other words, I need to have a request handler, so if you gave me a request, I can give you a response. Then we have this method right here, and we add middleware to it. So our stack, which is initialized to an empty array to begin with, our stack, we will add middleware to it, something that is a middleware interface. So we can call this and we can just build up a set of middleware to be called. Now, when our stack handler is executed, what's our process? Well, we look to see if my stack is empty. If there's nothing on my stack, then I'm just going to return whatever the result of the fallback handler is. So if there's nothing on that stack, just use the fallback handler and return whatever it gives me. However, if there is, I'm going to shift it off of that stack. And then I'm going to have that middleware process my request. But what am I going to give it? Because remember, for middleware, I need to pass it both a request and another handler. So what am I going to do? What's that other handler going to be? It's going to be myself. So essentially, I'm saying, hey, middleware, process this, and if you can't handle the request, if you can't give me a response back, then you'll call handle on that which will execute this method again. I will look to see, do I have I completed the stack? If so, use the fallback. If I haven't completed the stack, shift off the next middleware and do the same thing to them. Remembering that this middleware, it controls what gets passed to that next handler. It controls whether it's going to modify the request or whether it's going to modify the response when it comes back from that handler. It controls all of that. So let's see this in practice. We'll get rid of this example code. And I see a question here. You said almost everyone is using these patterns. Do you have any notable exceptions, and what would be the reason not to use it? Yeah, well, there are frameworks that took a different approach to middleware than this. I'm sure if you looked at the meta documents for PSR 15, you would see all the arguments as to why the PSR team picked this type of middleware. There's the other type of middleware passes both the request and the response, not just the request and expects a response. It kind of passes both down the chains. I don't want to say which frameworks don't use it because I'm going to have an incomplete list in my head, and I don't want to name the wrong ones. But there are certainly, when it comes to PSR 15, other middleware concepts in the ecosystem. When it comes to requests and responses, I don't know of a lot of difference outside of PSR 7 for code that is wanting to be modern, wanting to be portable and used. A lot of code has just kind of conformed to the PSR 7 spec. So let's wire this up. We have a new stack handler, and what are we going to put as our fallback handler? Well, a not found handler. So if nothing else happens, we will at least say it wasn't found. We're going to comment this out. I was running through it before and I forgot about that. We'll add the route middleware, and we'll say to the route middleware, your base path is PSR 15. And then we will add a resource middleware where we map traffic to the traffic handler and weather to the weather handler. And then we will just emit whatever our handler, again, our handler is the stack handler, whatever our handler gives back from the request that we create from globals. So then if we look at our example again, and we'll run them just like we did before, we get a not found. So that's expected, and it doesn't really matter what we put here. If it's not matched, we will get back a not found. We can run the traffic, and we see, yep, the traffic is bad, the traffic is good, changes just like before. The weather is sunny, the weather is cloudy, changes just like before. So we have exactly the same output, but now we have a much more modularized set of code that's a lot more testable and a lot easier really to break down. Because what would happen if we said, you know what, we need to log something? Where would we put that? Well, in more legacy applications, maybe we put it in the controller, right? Maybe we put it in a router someplace. We'd find a place wherever it made sense, and we'd inject a logger there and then try to log it. Let's take a look at what adding logging right now to our really simple API here would look like. We're going to create this as logging middleware, right? You construct it with a set of closures. And then when we say process, when it's handed a request to process, well, what's it going to do? It's first of all going to extract the attributes from the request because we totally want to log those. And then for each, this additional, so whatever closures we were given, we'll iterate over those. We will pass them the request, and we're just going to merge that data in to the data that we have. So we're going to take the attributes of the request, put them in an array, and then each one of these closures that we might have been passed when we constructed this middleware, we will pass the request to that. Whatever they give us back, we will also add to the array. And then we're just going to error log the JSON encoded value of that data. What are we going to do? We're going to return the response of the next handler. We're not going to do anything. All we are is going to log it. Now, a question came in that says, most objects in PHP are mutable. Why are the request response objects strictly immutable? It's because of things like this, right here. I've introduced middleware that's for logging, but what if I accidentally did something like request set data, or set attribute, sorry, which I can't do because that method doesn't exist, and I accidentally cleared it. Now the code that passed the request to me doesn't know that I modified it, because if it's an immutable object, objects are passed by reference. So now, and I didn't even spell attributes right, so that would never work. But now I've passed code to other code for them to do something that I think is benign, like logging. And because I was debugging something or trying to do something, I forgot to take out the debug line, all of a sudden now I'm changing it, and that creates problems that no one expects because, well, they didn't think it would change. Immutable objects means I can always be sure that the request I'm given is not going to change. And especially like this process, if I hand you a request, I get a response, or you hand the request on. Each middleware can be sure that when they do something with the request and they pass it off to some other library to do something, it didn't get changed. So that's the value of the immutability. And a lot of it comes down to, you can test it. You don't have to worry and test that, well, did they change it when I handed them that object? You don't have to worry about that because it's not going to change. So we add this logging, and we can just add the logging middleware right here. Add new logging middleware. We have a function there. It's a simplistic function. We just add the timestamp and the host, which we extract from the request. And now if we come back and we look at our example, we can start making some requests to traffic, start making some requests to weather. And if I bring up my dev server, we'll see not only do I have the logs that you'd expect the PHP dev server to be giving me, but I also have these other logs, which again are they're extracting the attributes from the request, they're adding whatever additional data my closure added, and they're error logging it. So now I'm able to inject logging, and none of my other code had to change. What else can we do? Let's take a look at what it would look like to add authentication to this. And then, yeah, it looks like we're going to have enough time to talk about something really fun that I'm excited to get to. So auth middleware. This is a really simplistic example, okay? This is not great code for you to start running with, right? We're going to expect an array of keys, and then when we're processing, when we get handed the request, what do? We take a look at the authorization header, and we extract that to a variable, and we look to see, hey, did it start with bearer? If it didn't, just pass it on to the next handler. Nothing I'm going to do with it, right? If it did, let's extract the string after the bearer, trim it so we have, just the key itself, and then look at our keys. And if we have a key that is that token, then let's modify the request. Not modify the request, let's evolve the request, right? So we're going to add the user, and that's going to be whatever the value of the key is. So when we construct this, we're giving it an array of key values, with the key being my API token and the value being my username, right? So we will evolve the request. It will be with the attribute user, and we're going to use whatever was found in the key, if there really was one. And then we're going to return the handler of the, we're just going to return the response of the next handler. Say, just pass it on. So I don't do anything other than see, is there a token? If there's a token, is there a valid one? If it's, if it's a bearer token, is there a user? If so, add that to the request. Again, this code is, from a testing standpoint, so easy to test. So we'll add it right here. We have the new auth middleware, and there's my really secret key, and it maps to me. And we can go to our example, and we'll see when we run this. If we look at our log, we'll see we have user TJ Lytle here. Now, if we change it from really secret to really secret X, because it's not, we run it again, look at our server logs, we'll see here we had user TJ Lytle, and here we don't have it. So we're able to inject authentication into it, and And if we wanted to do authorization, well, then maybe that would be handled in my resource middleware, which would say, hey, if there's not a user, throw a, 401, you're not allowed, back at them. So we don't have to do all of the authentication and authorization together. Our auth middleware here, which I really should say is authentication, because we're just authenticating the user. But my auth middleware here just has to add the context, and something down the line can decide whether or not we should stop based on that context. So again, hopefully this is encouraging to you if you've used this before, because all this, there's no micro framework here, right? Oh, and in fact, I forgot to mention, I'm sorry, this stack handler here, this stack handler is literally boilerplate code. If you go to the PSR meta document, this is what's there. This is where they say, oh, you want a simple way to use middleware? Just copy paste this code right here. So with a couple hundred lines of code, we're able to put together a modularized middleware process, and we don't need a micro framework. So if you're looking at saying, I have a legacy application, how do I introduce this stuff? Well, you can start introducing it slowly, because you don't have to worry about, well, how do I bring in a framework? No, just start making your code aware of this concept of middleware. Take your existing router or whatever it is and wrap that up in a handler, and then create a middleware stack where your handler is the fallback. Ooh, and now you have a middleware stack where you can inject things and slowly pull stuff out of your legacy application. In fact, after I gave roughly this talk 2 years ago at a conference, that's what our team did. On a legacy application that's been around for years, we introduced basically this handler to start moving away from our old router, our old kind of controller concept, to a more request handler concept. But the fallback handler is our old router, so everything just worked, and we could inject middleware on top of it using what amounts to the strangler pattern. We got some questions coming in. If the order of our middleware important, how best can we control that? It is important. How best you can control that? Well, it kind of depends on your context. And if you are going to use a library, different libraries have different ways of making sure the order is preserved in the way that you need it to be preserved. Creating new objects in many steps. Are there any memory concerns? Not really. PHP is pretty good with that. You can easily create a lot of new objects if you have a lot of middleware that enriches stuff. Yeah, you can. Although you see me using the with attribute, I believe you can do, I think there's a with attributes, and you can just like add a bunch of them. But in practice, it's not that much of a concern. Do you agree that a PSR 15 should be created to handle request interface implementations? PSR like PSR 15 should be created to handle request interface implementations. So implement middleware on an exchangeable way. Oh, instead of server request. I don't really have strong opinions on that. It sounds like a good idea, but I've not thought that through. But I think I understand what you're saying. You're saying, so instead of having to pass server requests, we can have middleware in the chain of a client. I mean, on the face, the idea sounds good. I've not explored it enough to have a strong opinion. Now, we've got 3 minutes. I'm going to do this really quick. I'm so sorry. I wanted to be more. But let's just take a look at this. Someone was asking about choosing the right library for PSR 7. There's a bunch out there. I would choose the one that tends to be in whatever framework component library you tend to use a lot. Find the one that you're familiar with. But sometimes you come in and you're like, well, I'm using my PSR 7 library, and I don't like this because, look, I have to get the params for query params. I have to get a value from it, and then here I'm saying, well, if the value is set, use the value. If not, it's default, and then echo the value. So this right here will work, and let me just do that and hit this example so we can see it. So we have a value here that's not default. Let's run it. We got not default, and for some reason, echoing other stuff down here. So let's try that again so it's cleaner. So we got the default value because, come back here. So we'll do this one where value equals not default. We see not default here. We're not passing that value. We're passing the wrong key. So we get the default value. But the point of this is this right here tends to be a little bit tedious every time we need to do it. You know what I would love? I would love this right here. Get query, give it the value or the key that I want, and then if it's not set, give me the default. Problem, that's not in the PSR7 spec. So if I'm going to be using a PSR7 library, all of a sudden I can't just change it because it's somebody else's code. Well, what do I have to do? Do I have to write my own PSR request response? No. Here's a library that we have open sourced at PhoneBurner that we haven't talked much about, and this is the first time I'm actually talking about it. We've been using it for probably over a year now. So here's our burrito class, which you can see, well, we're going to add this public function of get query with a string, and we're just going to do what my code was doing, right? Get the params from myself, check if it's set, if not, default to a default value, which I should have done this, sorry. Live code, folks, live code. So that's now a working function the way it's supposed to be. But I don't want to have to write the rest of the request and fulfill the rest of the request spec, all the with attribute, all of this, all of that. And Burrito, here our Burrito class, uses our server request wrapper from our framework, which is called Tortilla, HTTP Tortilla. It allows you to wrap any PSR7 request really easily. And we'll look, all we have to do is say, when you construct me with another request interface, another server request interface. I will set my wrapped interface to that. And this is important, I will set a factory that creates a new version of me if given a request. And it's this magic right here that makes all the with attribute, with query param, all the withs work. So now I can come back to my example, and I actually can use that. I can get rid of all that, and I can just now use my new method that I made on my PSR7 implementation, which wraps the Zend one that I'm using under the hood. And if we come back here, we run our request, we will get exactly the same thing. When we set a value, we get that it's not a default. When we don't set the value by key, we get the default value. And we can do that easily without having to worry about implementing all of the rest of the PSR methods. The other thing you could do, and here's an example of it too, is I really quickly was able to say, well, I wish it decoded JSON for me. Well, now it does. And I can just add the code right here. And if I come back and go to my example, I can var dump the parse body. Doesn't matter, even if it's JSON. So we come back to our example and we say, oh, secret data. Do we see it? Yep, we got an array of secret data. What if I pass it form URL encoded? Oh, look, I did not change the behavior at all, because what does the burrito code do? It checks to see if, first of all, if the wrapped request already had a parse body, and only if it's empty and only if it finds JSON in it does it create a new request with the parse body and then set that wrap to that. One really interesting thing that we've done internally is we have respondable exceptions, which extend exception but implement the response interface. So we are able to have an exception thrown that we can also then pass to an emitter and emit a response to the end user or to an API based off the exception that is thrown, because we just wrap it in the response wrapper. So if you're doing stuff with PSR7 and you're like, I just wish it had this one convenience function that I want to use, then check out our library called HTTP Tortilla. It is on Packagist. And with that, I am sadly out of time. Do you agree that, yeah, I think I got all the questions answered. And I'll just put this up. I am Tim Lytle. I work at PhoneBurner. If you think you should work there, we're generally hiring. Cal has even said this company knows how to hire developers. He tweeted that out a while ago. There's where you can install Composer, install PhoneBurner/HTTP Tortilla. If you want these slides, go to timlytle.net, and I should have that updated over the weekend, and rate this talk on Joined In.
Thank you, Tim. Boy, that was a whirlwind of a talk, but I'm going to have to watch that one when I post it on YouTube because I missed some of the nuggets, but probably that was because I woke up at 2 o'clock this morning. So you got the easy job. Hey, I want to thank you, Tim. I want to thank all of our speakers for being a part of DPC 21. I think you'll agree with me. We had some great talks, a lot of what I like to call actionable intel, things that I can take back and start applying immediately. So I'm really excited about these talks. Do me a favor, if you're in the Slack channel, please say thank you to these speakers, because that's pretty much the only payment they're getting. So, and those of you who said nice things about me, I appreciate it because that's the only payment I'm getting. We're all doing this for fun, but we do appreciate knowing that it has helped you. So please reach out to the speakers, tell them thank you, reach out to them on Twitter if you want, or in the Slack channel, let them know that they did a good job. Now, this is the exciting thing. Next year, live at the Rye, in person, June 30th, July 1, and July 2. We hope to see you there. I hope to see you there. I hope I'm allowed to be there. But more importantly, I hope that all of y'all will join us at the Rye next year for an in-person Dutch PHP conference. And I can't tell you how excited I am about this. So, and I think, where'd my mouse go? Lost my mouse. There we go. With that, I'm going to bid you adieu. Hey, I want to see you online. Make sure you tell everybody hi. Make sure you find us on Twitter, find us on Facebook. Make sure you tell iBuildings, especially, how much you enjoyed this talk. Okay, I'll talk to you later. Bye-bye.